The first 5 metres we've got a fall of might pay to turn that off, hey? So you can see that. Overhead. Oh good, you can see the board as well. Okay. So according to the assessment, we're coming downhill by negative 29%. So we're coming downhill by minus 29%. And it's over 5 metres. So the first thing I'll need somebody with a calculator to do is to multiply 5 metres by 0.29. And we should get an answer which will give us how much we drop. The actual level is 49.5 up the top. So it's a little bit hard to see here. I'm going to change the red to white or yellow or something that you can see. Is that a bit better? Yeah, that's better. Teacher asked too much rhetorical questions. Okay. So the PT R1, is still in red. So that's no good. So let's change that away from red to white. Okay. Okay. So over here at R1, we're coming downhill at negative 29%. The R1 level, according to the assignment, is 49.5. So I need somebody to do the mathematics for me, please. I mean, I could take another example if you want to. We could do something completely different, and I'll do the math, or we could do the assignment and somebody here could give me the answer. So we want 5 metres times 0.29. Big bump?
1.45.
1.45. Okay, so that's the drop. 1.45. I'm assuming you're correct. Right. So if that drops 1.45, and this is 49.5, I think.
48.05.
So this will be 48.05. Perfect. So therefore, that first point there is 48.05. That perhaps I should draw a bigger blow up there, I don't know, but I'll do that in a minute. We'll call that 48.05. So yes, it is a funny little number, but it's not the end of the world. So let's draw that a bit bigger. In fact, let's start drawing that up. We've got a starting point for the centre of our road. We know the road's 3 metres wide. We need to draw a cross section through here. looking that way, because that's the way the road goes. So let's draw that up. That'll give us our first clue as to where everything is. Alright, so over to the side. Now, here's the next thing. This is a P-line. You make this into a P-line. Ingrid would have taught you that in order to make a P-line, you can type P-edit and join up the lines. So if you've drawn them individually, from R1 to T2, and you've done the next one and you've done a curve, you can join them all up, and that'll give you an overall length. What Ingrid didn't teach you is the measure command. So I'm going to draw a line down here. Oops, I'll just get rid of my bubble and squeak. I don't like the blooming bubble and squeak, sorry. It's a nickname of mine for is a pain in the butt coming on all the time. And now, when you want to get rid of something, it won't. Oh, there it is, over there. Okay, so we'll go to dynamic input and take these things off. You should have already done that on your home computers. And I'll move that down here. Okay, right. So I'm going to draw a line down here vertically. I'm just picking a random length. Let's call it 20 for the sake of calling it 20. Enter. Now that means I'll be doing the cross section 10 metres either side of the road. That should probably be enough to pick up any trees or anything like that. I'm going to make this block and call it cross. So remember when we did, I may have demonstrated you this when we did the batter slope symbol. Anyway, I'm going to type block B-L-O-C-K, B-L-O-C-K, enter, and nothing happened. Oh, here it is. My things are bouncing around. Let's call this cross. Let's pick a point as the midpoint on here, and let's select it, enter. You get a wee picture up here and just go OK. So we've now got something called cross. Now I'm going to type measure, M-E-A-S-U-R-E. Now what could go wrong here is that you have drawn your road starting from the left and coming back to the right. So you do need to make sure that when this goes on there, it starts doing it every 5 metres from the right. I've drawn mine the right way around. You may have to redraw it or redo the order when you go P-edit and you pick the things, go from right to left. So I'm going to click on here, and down the bottom it's asking for the block, B, enter. The block name is called cross, enter. Measure, yes. I want it to, when I align it, it means it's going to go round and align itself at right angles to it. So Y, enter. And the measured length is 5 metres, enter. And there we are, it's on there now. Can you see that? I'll zoom in on it. It's a little bit hard to see. Maybe I could make it another colour. Let's make it green or something so you can see it. Okay. Oops. Didn't work, did it? So you're only going to have to draw up 4 cross sections. For some reason that is not turning green or, okay, let's do it another way. Oh, it's a block, isn't it? Yeah, it stays the same. Okay, can you see those lines down there, or are they a little bit too confusing? It's going and it's turned the corner. Okay, it is a bit confusing. I'm going to explode them and change their colour. So I've got the first one there, the second one there, the third one there, the fourth one there. I'm going to offset, the road is how wide? 3 metres. I'm going to offset that 1.5. So there's our road. And I said to you I'd do between there and there. Okay, so I'm going to draw that first cross section up. I'm going to copy that 2 times, 1 to there and 1 to there. I'll move that long section out of the road, what we drew last week, or last time. Move that along a little bit. Right, so in order to get this cross section looking that way, I draw a line across here. I type the align command. I grab that. I go from the end point to the end point, from the end point to the end point, enter, and scale it, no, enter. Okay, so I've flipped it round. Actually, I grabbed the wrong cross section, so I'll just move it from there down to there. Okay, so there's my first cross section that I'm drawing up. Oh, I did do the right cross section. That's alright. Let's just pretend that that extends to that line there to make it a bit easier. And let's start drawing up from here. We have 47. 47. And I'll draw that one up from here, which is 47.5. And I'll draw that one up from here, which is 48. And I'll draw that one up from there at 49. And we don't really have a level here, so we have to assume that that carries on at that slope. So there we are, that one, that's 48.5. And we don't really have a level there. Okay, so that's the best we can do. Do a P line from here to there, to there, to there, and we can do a line out here somewhere, assuming, oh no, the path's level, isn't it? So we take a line up from the path. So extend the angle up to the path, and then do the path as level across there. So there's the cross-sectional area, basically going through that first cross-section, number 5 metres. Now we need to come up from the road. So here's the road. I'm going to come directly up here from the road, and I'm going to come directly up from the other side of the road. Now the level that the road is was calculated before by my friend here. So that came at 48.5. So I'll take a line up from the centre line there at 48.5. There it is there.
48.05.
Oh, thank you, well corrected. See, I often deliberately make these mistakes so that students correct me to make the class more interesting. 48.05. Unfortunately, students can smell BS. So I'll better stop that. I'll put that over there. So there we are, there's the road. I've got it all mapped out. So now, just like my little sketch up the top, we need to do our batter slope. So looking at the assignment, I don't know how many of you got this up on your screens, but the assignment batter slopes, oh here we go. Fill batters for the road of 1 to 2.5. Hello, that's a little bit different, 1 to 1.5. So the 1 is always in the vertical, the 1.5 is in the flat, or the horizontal. So let's put that away over here, park it over there for the meantime. Okay, so we're going to go along, now remember the cross sections, nothing's distorted, it's all 1 to 1. So we can go along 1.5, so we'll call that say 15, you'll see why in a minute, and up 10, which is like 1, and then back down to that point. So that gave me the angle. Now I could have gone along, I could have also done it another way, could have also gone along 1.5 and then up 1 and back down there. I thought for a minute it was not going to reach, but it did, so that's fine. Now over here is the same, so we go along 1.5, up 1, and back down. Now we have a bit of a problem here in that it's going to go right the way to the footpath up the top. So, okay, that's my cross section. Now to put our contours on there. So this is at 48.05. So to get to the first contour, it'll be 48.25. So it's good with CAD because we just offset. So we've got 48.25, we've got 48.05. So how much is the difference between those two? 48.05 and 48.25. 0.2? Yep. So let's offset 0.2. And let's click there and take it along. So that is an interesting line. I'm actually going to give that a slightly different colour of green, yellow. So you can see that it's a contour line. Now, all we have to do here now is just to offset by 0.25. Up. 1, 2, 3, 4, 5, 6, 7, 8. Extend then over to the batter slope. Top one doesn't matter, it's gone. And we don't need anything, you can trim that off. So that is, the yellow lines represent the contours, 0.25 contours. And where they intersect here represents the point at which we need to mark on our long section, on our plan, sorry. So we need some distances. Now, I'm going to suggest that that distance is really easy. That should be, I'm going to dimension it. Okay, if you can excuse the large text, it's 0.38. Now why would that be 0.38 and the height is 0.25?
345.
Not quite, but what you're indicating is that the triangle of the batter is 1.5 by 1. So if the 1.5 bit is 0.25, if the 1 bit is 0.25, then the longer bit becomes 0.38. So we now know that the offset is 0.38. That's going to make it easy. If we do the dimension from here to here, that's slightly different. In fact, I'll take it so we can see it way down here. So the first dimension is 0.3, the second one is 0.38, and then every other one will be 0.38 from there on. So how does that affect our plan view? Well, on our plan view, we have to come off from this line here. So we go offset 0.38. Sorry, first one's 0.3. Now I'm going to break that line either side of here. So it forms a marker. And then we're going to offset 0.38 from now on. 1, 2, I don't know how many of them are. I'm just marking them out. I'll count them in a minute. So let's see how many. See how I've marked them off from the side. So the first one was 0.3, then 0.38. I'll go back to my wee sketch. How many of them are there? The 0.38s are 1, 2, 3, 4, 5, 6, 7. And then the last one is 0.31 to get to where the butterfly wing is. Let's go back there. 7 is what I'm marking off. 1, 2, 3, 4, 5, 6, 7. And this last one I offset by 0.31. And I'm going to put a circle there, because that's a very special one. That's when my butterfly wing is. Now on the other side, the first distance is going to be 0.3. I'll just prove that. Right? Because it's the same as the other side. And then the last distance to that point there where it hits the butterfly wing is going to be what looks to be 0.4 all up. So I'm going to have to offset 0.3 and 0.4. Back to here, back to the road. Offset 0.3, offset 0.4. I'm going to copy these little things here from there to there Okay, and that's a very special one because it's got the butterfly wing on it. So we now need to move on to the next one. So we need to now do a calculation for it coming down, and now we've got a new level up the top there of 4 point. Our new level for the next one is down here. And we're coming down another minus 29%. And we get a new level down here by doing the equation, which is 5 meters times 0.29. Now we already know that equals 1.45, so we have to go 48.05 minus 1.45, and we get a new level down here of 46.6. Okay, so 46.6 it is. Remember that. We go across to our other cross section, the next one. We draw a line. We go a line. We grab that. From this time, it's from that point to there. And from that point to there. No to scaling, and there it is there. Okay, so let's draw this cross section up. So a line from here up 46.5. A line from here up 47. A line from here up 47.5. A line from here up 48. A line from here up 48.5. And a line from the edge of the path up to a P line from here. Extend that to the edge of the path. And draw it flat from the path. Trim that off. Okay, centre line of the road. What was the 40 something 0.6? 40, what do we get down the bottom there? 46.6, yep. So we'll take a line from here at 46.6. Okay, offset that, do a line across here, 1.5. A line from there across 1.5. A batter slope along 1.5, up 1, and back down to wherever the 3 was, there. So it's not as prominent this time, is it? It's 1.5, up 1, back down to there, and raise that, trim that. And we have our new cross section. Okay, now this is 46.6. So the next contour is 46.75. right? So how do we get to 46.75? 0.15? Yeah, 0.15. Offset 0.15, and that is our new contour. And now it's exactly the same as the other cross section. From now on we offset 0.25. Let's take that a little bit longer, change its colour. Offset 0.25, and so we've now drawn the contours for that. And we'll trim that off. This will be interesting. Yep, comes in just in time. Trim that off. Right, so that's all the contours drawn in. So let's have a look and see what the first one is. So to do that, I always take a line down and then I do a dimension from that point to that point. And that is 0.23, and it's exactly the same on the other side. So if I go back to my plan view, here we are here. So if I take off offset 0.23 on both sides, and then of course it's going to be 0.38 from then on. I'll copy my little thingies over to there. And offset 0.38, isn't it? Yeah. So how many of them are there? Not so many this time. Right hand side, there's 0.1, 2 of them, and that's just about it. So there's only 2 on the right hand side, and how many on the left hand side? 1, 2, 3, 4, 5, 6 of them. 2 and 6. Easy to remember. Left hand side's got 6. 1, 2, 3, 4, 5, 6. So that one doesn't exist. And right hand side has just got the 2. Okay, so it's now a case of joining up the dots to whatever each one of those contours is. So we have to, when we mark these contours on here, it's quite important to mark what they actually are. So when we go back to our cross sections and we get rid of all these numbers off here, it's important for us to mark what that contour value is. So, that we can mark them then on the plan view as well. So let's have a look at this very first one. This was 48.05, so that was 48.25, right? .25. Scale that down a bit. So that one's 48.25. I'll scale it down a wee bit more. And that one will be 48.5. And that one will be 48.75, and so forth. Okay, so when we mark these on our plan view, it's important that we mark them. See these dashes here? So that's 48.25. That's 48.5 naught, and that's 48.75, and so on. You understand that? That one over there is 48.25 as well. So we need to join up these ones with whatever the ones are over here. So over here, on our second one, what was the level of our second one? 46.6, is that correct? Yes, 46.6. So what's the first contour? 46.75, is that correct? Okay, so the first contour is 46.75. And then the next one's 47.0, 47.25, and so on. And that's 47.25, and that's 47.5, and that's 47.75, and that's 48.00. And that's 48.25. So those numbers need to be transferred over to the plan view. You're going to see something rather interesting in a minute. 46.7, 75, 47, 47.25, 47.5, 47.75. So when you're joining them up, the 48.5 is 25 is going to go from here to there. So that shows you how much the lines pan out. The lines are always parallel, so we can now copy that from there to there to there to there to there to there to there, and they trim off at the road. So they're very different than the design contours on your platform. Trim them off at the road. And 48.25 is the last one, I think, for the batter slope. So I'm just going to do this side batter slope. Where are we? Over here. So that distance there to the batter slope from the platform dimension from there to there is 2.72. So let's go back to the plan and offset 2.72 from the road. There it is there, special circle there. Okay, so that means that our batter slope goes from that point, this is the butterfly wing, sorry, to that point there. So I've drawn the butterfly wing on. Now the next issue is to copy these contours down parallel to the first one that we established. And then trim those contours off at the butterfly wing. So I've done one whole side for you there of butterfly wing contours, or what we call design contours, and you can see that they will continue on to the last one at the top. Now, where the path stops, I would suggest we're going to have to cut into that a little bit to form our last batter slope. So this piece of the path will be cut into. So those design contours will carry on all the way around the road. And I do admit this is the hardest bit of this whole project. They will be parallel and they'll pan in like this. They will change slightly as they go around the corner, and then they'll pan in like that again. Remember, we're doing every 0.25, so you do need to draw in here some 0.25 contours to match into them. Okay, this is more marks are allocated to this part of the assignment, but if you don't feel that you want to have a go at this, then that's fine. I have demonstrated to you how to do one section, and pretty much it would be the same on this side. That would match into something over here, and they would end up being parallel as well. Normally what happens is they both fan in the same way on each side of a road. When you get into when we get into fill, there's no fill here at the moment, they fan the other way. So when you look at any road plans, which is, as surveyors, I'd probably say that if this whole class graduated, at least half of you will be doing roading, and you'll be opening up road plans, and you're going to see these design batter slopes will fan in like that. For the other half of you who do roading and who do housing and platforms, it's a bit easier, as you know, because they'll be parallel with the platform like we did in the first bit. So if I've managed to get that across to you in your careers, and you're able to open a drawing and see what things look like, what a design contours look like, then you're halfway to setting it out for the owners. Okay? There's some pretty easy marks just in your proposed plan and your long section, and also drawing up those cross sections. You all understood what I was doing as I was drawing them. I've basically done 2 of them for you. Don't forget the trees and things on the cross sections, they're quite important. What we didn't do is, so for example, the first one, see here, there's a tree here, and the cross section goes across here, and we're looking that way. Then we need to pick up that tree and whatever level it is on the cross section, okay? I've put there's another tree here, which I think was additional. That will be picked up on that cross section there. Otherwise, there's no other trees there's no other trees you need to worry too much about on the cross sections. And also the pipe, this new pipe here in yellow is going to appear underneath the road. So on the long section you've got to work out exactly what point on the centre line where that pipe crosses through. But it's all grades, you're just working out the grade. So I held that back to after the holidays or after the break, because it was quite a bit to take in during the break. So you've got the past leader there can help you if you need to with what I've just drawn. Or you can go back through the videos if we can get them uploaded and watch that again. It's a little bit tricky because of the screen and the brightness behind me, but that's what I've ended up doing. And these marks here have been caused by me putting the design contours onto the cross sections. By the way, you don't have to draw these contours on. These are for working out where they go on the road. So what you need on the contours is on the cross sections is hatching and dimensions, and remember everything comes off the centre line of the road, left and right. Today's notes. Make them available. Now in the past I've had a second test in the subject. We're not doing a second test, so a lot of these notes are really just notes you can put on your drawings in that respect. So I made available a cross-section example, and that shows the trees. Remember, the trees are 1-to-1. It's got a bit of hatching for the ground, and it shows the centre line of the road. The only addition I would probably make to this is right centre line of road on that centre line piece there. And yeah, that's pretty much what's needed on each cross section. The trees, the road, and some ground light hatching, and some hatching for cut or fill. And the notes, have a look at the notes. You might be able to glean some notes off there that you can use on your own drawing as well. That's from an A student's work, so that's where you've got to be at. And that's how we call up any crossover pipes that might be on there. Back to the notes for this week. So the week 11 notes gives another cross-section example there, and I go into some a little bit more detail on why we do cross-sections and some of the 3D design packages available at the moment to do cross-sections of. For example, Civil 3D and 12D. And probably in the future, this part of the course will turn into more of a Civil 3D type course, where I give you some digital data and you supply me back some cross sections and long sections from that. It would be still roading though. I still think it's important to cover the roading side of things, because you don't often get a lot of that in your normal surveying with the other lecturers, because roading tends to cross over into engineering design. And the notes also go into the cost of a survey and figuring out, you know, what sort of survey you're going to use, whether it's, I don't know, a drone or LiDAR from the satellites, or whether you're going to send the whole team out there for a few weeks or whatever. And a lot depends on the cost and the extent of the job, the type of terrain that you're going to be working in, etc. There's a little bit of history there for you. Take it with a grain of salt. I first got involved in surveying in the 80s, but we were switching to a lot of digital stuff at that point. I got involved with aerial photography and digital data based on the photography in the 2000s, and then of course LiDAR came in when I was lecturing here at Unitec, and I got